Good afternoon, everybody. On behalf of the Math Club and the Staff Development Committee of the Department of Information Technology, University of Technology and Applied Sciences, Muscat, on yet another wonderful Thursday afternoon, it gives me, Dr. Kolappan Velayudham, a great feeling of pride to co-host the virtual talk titled Graph Theory in the Information Age, to be presented by one of the finest mathematicians of our age, Dr. Ambat Vijaykumar, Emeritus Professor of Mathematics, Cochin University of Science and Technology, Kerala, India. Due to some other important engagement, our head of department, Professor Talif, is not available. So I would like to request Dr. Bushra Hibras Al-Sulaimi, Head of Math Section, Department of Information Technology, University of Technology and Applied Sciences, Muscat, to present the welcome address.
Thank you, Dr. Kolappan. Assalamu alaikum, esteemed guest of honor, respected head of the IT department, Mr. Talib Al-Mahrouqi, distinguished dignitaries present here, dear staff members, and our beloved students. It is indeed a great pleasure to welcome you all for this virtual talk on graph theory in the information age, organized by the Math Club and Staff Development Committee of University of Technology and Applied Sciences, Muscat. I am profoundly delighted to take this opportunity to welcome our resource speaker, Dr. Ambat Vijaykumar, Emeritus Professor of Mathematics, Cochin University of Science and Technology, Kerala, India. We would be delighted with your expertise and knowledge in every way possible. Thank you, dear all, for being with us today. Thank you, Doctor.
Dear faculty members and students from various colleges and universities of Oman, India, and all over the world, may I invite Dr. Kamal Kumar, Faculty of Mathematics, to formally introduce Dr. Ambat Vijaykumar to the audience. Dr. Kamal?
Yes, I'm here. Yeah, it's my proud privilege to introduce the honorable speaker, Dr. Ambat Vijaykumar. Ambat Vijaykumar is currently an emeritus professor in Department of Mathematics, Cochin University of Science and Technology, Cochin. Professor Ambat Vijaykumar field of interest is discrete mathematics, graph theory, graph spectra, energy of graph product, domination, theory in graphs, complex networks, history of mathematics, mathematics education, popularization, and talent. Professor Vijaykumar has occupied various prestigious positions in reputed organizations, few to mention. Head of the Department of Mathematics, Cochin University of Science and Technology, Director, Center of Interdisciplinary Studies, Cochin University, Honorable Deputy Director, Center of Science in Society, Fellow, Institute of Combinatorics and its Application, Canada, Vice President of Ramanujan Mathematical Society, Regional Coordinator of Indian National Mathematical Olympiad, Mentor of Inspire Program, conducted from Department of Science and Technology, Secretary and President in Kerala Mathematical Teacher Association, Council Member of Indian Mathematical Society, President in Kesri Memorial Library, winner of Broad Outlook Learner Teacher Award from Air India. Professor Vijaykumar is also reviewer and board member in various national and international journals. Dr. Ambat Vijaykumar produced 15 PhDs, authored and co-authored more than 100 publications, H index 16, I-10 index 27, more than 1,500 citations. Dr. Ambat Vijaykumar is a life member in various prestigious societies like Indian Mathematical Society, American Mathematical Society, Ramanujan Mathematical Society, Canadian Mathematical Society, Cryptology Research Society of India, Mathematical Association of America, Indian Science Congress Association, Academy of Discrete Mathematics and Application. Professor Vijaykumar has delivered various talks in national and international conference, not only held in India, but also in various foreign countries, few to mention, like Hungary, Canada, Italy, Taiwan, Swiss Republic, Mexico, South Korea, Germany, Spain, and Slovenia. Not only delivered the talk, but also led the Indian delegation to NTHU Taiwan in 2013, member of Indian delegation to Seoul, South Korea. Also to note that Dr. Ambat Vijaykumar has various collaboration with many foreign prestigious universities. Ambat Vijaykumar has interacted with very eminent personalities, few to mention. Honorable ex-President Dr. APJ Abdul Kalam, Professor C.R. Rao, Professor Robert Devni, Professor Michael Barnsley. Professor Vijay Kumar has been interest in interacting in students during the COVID. Professor Vijay Kumar interacted with school children, college students, teachers through more than 50 webinars, which reached more than 10,000 participants. His efforts in break the chain in COVID-19 is noteworthy. Professor Vijay Kumar has written more than 65 popular articles in various aspects of mathematics in Malayalam and English for students. His articles on APJ Abdul Kalam, C.R. Rao, and Srinivas Ramanujam is very popular among the students in Kerala. Thanking one and all for giving me this opportunity to introduce the honorable today's speaker, Professor Dr. Ambat Vijay Kumar. Thanking one and all.
Dear Professor, it's your time to mesmerize us with the help of graph theory, please.
Thank you very much, and good afternoon to all of you. Let me first of all extend my hearty thanks to Dr. Talib Arif Hamad Al-Mahrouki, Head of the Department of IT, Dr. Bushra Hibras Al-Sulaimi, Head of Maths Division of IT Department. So thank you very much for virtually taking me to Muscat and Sultanate of Oman and the University of Technology and Applied Sciences. I wish to say a few words about University, Cochin University of Science and Technology in the mid part of Kerala, where I studied for my master's and PhD, and I've been serving as a faculty since 1998. As I was introduced, my area of interest is discrete mathematics broadly and graph theory. So I will spend a couple of minutes with you all. And during discussion, any point of doubt or clarification required, I'll be happy to give it whenever required. So let me formally start my presentation. So this is the beautiful building of the Department of Mathematics, Cochin University. I've been emeritus professor since 2018, and this is the logo of our university. Let me also formally thank you all for inviting me for this program. I understand that there are some participants from Kerala also. So let me proceed further. The person who introduced me told you all about my interactions with the Honorable Dr. Abdul Kalam, the most inspiring teacher of the present century, who was born on 15th October 1931 and passed away on 27th July 2015. In fact, we celebrated the 91st birth anniversary of Dr. Kalam a couple of days ago all over India. His quotes are quite inspiring, as well as his talks. One of the quotes that I have taken for today is that you cannot change your future, but you can definitely change your habits. And surely your habits will change your future. So that's a very significant quote from Dr. APJ Abdul Kalam. So broadly, this is my agenda. In fact, networking started with handshakes. So given the time, I will divide the talk into three parts. One is the classical graph theory, its origin in 1736 by Leonhard Euler, which finds a lot of applications in several types of networks. Then briefly about random graphs, which I may not touch upon more, but I will spend more time on the discussion on complex networks, what we call the small world phenomena and scale-free networks, real world networks, like brain networks, World Wide Web, and the epidemiological networks. Of late, in 2020, when Professor Martin Nowak has found applications of network theory to explain the Darwin's theory of evolution, which is more surprising and exciting, And this has given rise to a new branch of mathematics called evolutionary graph theory, which studies the evolution of human being. You find that in all these real world networks, there is a law which governs the distribution. That is what's called the power law. So the power law is well stated in the Holy Bible. It says that for everyone who has will be given more, and he will have more than enough. But anyone who has not will be deprived even of what he has. That is Matthew's 25th chapter and 29th verse. But there is an interesting article by Robert Merton, American psychologist and sociologist, entitled The Matthew Effect in Science, which was published in the most prestigious journal, Science, in 1968, which says that there is a power law everywhere in the system. So we broadly ask how old is mathematics, it is about 20,000 years ago. And all of us know there is a seemingly bipartition of the whole domain of mathematics into continuous and discrete. What we do in engineering courses is like calculus, differentiation, analysis, mechanics, and so on one side. And on the other side, we have graph theory, network theory, combinatorics, coding theory, cryptography, algebra, and all such things. But of late, we see that we are going to apply continuous mathematics techniques to solve discrete problem, and discrete mathematics techniques to solve continuous problem, because world is, according to Newton himself, he says that world is discrete, though he is a propagator of continuous mathematics and differentiation. As I said in the beginning, everything started with handshakes. So today I have shake hands with Dr. Kamal Kumar, Dr. Bushra, Professor Kolappan, and Sajid Mohan and others virtually. So whenever two people shake hands, there is a relation, we have become friends. And no shake hands says coronavirus. So you can shake hands like this. Each person shaking hands with the other person and finally coming back to the first person. So this structure, what we call this type of handshake, is what we call cycle in network theory or graph theory. Now look at this diagram. This diagram says first person shaking hands with the second one, second with the third, third with fourth, and so on. But unfortunately, the last one is not shaking hands with the first one. Therefore, you don't get a cycle. What we have is a path. What we have here is everyone shakes hands with the first person, one common person. So this is a structure what we call star. So this is two persons shaking hands. This is a cycle. This is a path in that this is a star. So I start with a small puzzle. Sajid Mohan invites 6 guests to his birthday party. Joseph, Vijay, Kamal, Niyas, Soumya, Shruti. When they arrive, they shake hands with each other. So one of the friends, Joseph, asks, how many handshakes does this mean? So Kamal says 7 multiplied by 642. Niyas feels this is too much. And Soumya wanted more time to think as if it's a great problem. And Vijay took an anticipatory bid saying that I don't know, this is very complicated for me. And Shruti settles with an answer 21. What is your answer? You can write it in your chat box or tell me later. It's a simple puzzle which starts the theory of graphs. So when several people shake hands with several other people, what you have is a network. We know the friendship network, the computer network, and so on. This is the hugest, largest network, what we call the World Wide Web, which connects several countries like Sultanate of Oman, India, Africa, Australia, USA, so many people and so many countries. So this is the infinite imaginary library that is there in the form of World Wide Web. Whatever you want to get in a fingertips, you are getting the answer from the modern technology, that is information technology, that is the internet and World Wide Web. If you look at the discipline network, sports science, social science, molecular biology, biophysics, computer science, artificial intelligence, machine learning, mathematics, biomedical engineering, neuron imaging, environmental sciences, hundreds and hundreds of disciplines getting related to several other disciplines. You know, computer science and mathematics are related, mathematics and physics are related, mathematics and chemistry are related. Therefore, there is a huge discipline network. I'm happy to share with you our research collaboration network of the Department of Mathematics. We have 12 faculty members, including emeritus professor like me. And the department has a wonderful research collaboration with several researchers at many places like Australia, Canada, France, Germany, Israel, Slovenia, Ukraine, USA, Russia, and so on. So this is our collaboration network. And through this talk, I'll be happy to join hands with the Department of IT and Mathematics of the university in Muscat, Sultanate of Oman for research purposes. So it's an open invitation to join hands with us. We can work out the details later. All this was possible due to the wonderful insight of the Swiss mathematician called the analysis incarnate, or the avatar of analysis. You may not know that he was totally blind for more than 16, 17 years. He lost his right eye in 1738 and the other eye in 1766, and still continued in mathematics for more than 17 years. So the moral of the story is, what we people or what mathematicians, great mathematicians have is a third eye, which could be somewhere in the brain. He is famous for his classic introduction to analysis of the infinity. This is the book that here I have shown. This is the stamps in honor of Dr. Leonard Wright. As you all know, graph theory started with the solution of a problem of crossing bridges, what is called the Königsberg Bridge problem. And mathematicians say that the Königsberg Bridge problem completely changed the structure and applicability of mathematics. So you see here different examples of graphs. This is what's called a tree. There is no cycle connected, it's a tree. This is a graph with cycles, this is, and so on. Okay. The title of the book that I showed here is Graph Theory 1736-1936 by Biggs, Lloyd, and Wilson, 3 British mathematicians. Graph Theory 1736-1936. 1736 is the origin of graph theory, and 1936 was the first book in graph theory by Jens Koenig, Theorie der endlichen und unendlichen Graphen, theory of finite and infinite graphs. But something surprising took place when I knew that there was the 0th book of graph theory, which was exposed to the mathematical and research community by my friend Martin Golumbik from Haifa University, Israel. This was informed to the mathematical community just 1 month back. So, since people have started calling Koenig's book as the first book, we cannot change it because we have been calling like that for decades. So, the caption of the book was 0th book of graph theory, which explains the work of André Saint-Leger of France. I recommend all of you to buy this book and read the book. So several years have taken place in the heading I see. 1736 is the beginning, 1926 is the new book, and 1936 the old Königsberg book. 1959 the theory of random graphs came, which connects probability theory and computer science and mathematics and graph theory. In 1998, several computer science people from USA and other countries talked about small world phenomena and scale-free networks. How does the complex networks work? This is the area which I'm going to concentrate on in my talk. And as I said earlier, 2020, what Martin Nowak of Harvard University did was to connect the theory of evolution of Charles Darwin with that of network theory, and that is the most surprising and exciting part of it. So there are several pioneers and books. To recommend a few, this is Paul Erdős from Hungary, this is Claude Berge from France, this is Frank Harari from USA, this is Bill Tutte from Canada, and this is Bondi, USR Bondi from, Adrian Bondi from England. So, and these are the two books which I have taken as an example. There are plenty of books on graph theory. I start with a small puzzle again. Suppose you want to color the different states of India with the condition that states with the same boundary should not get the same color. So what is the minimum number of colors required to color the India map, or for that matter, any map? That was a question asked by a 7th standard student, Francis Guthrie, in 1852, which was asked to his teacher, De Morgan, and De Morgan did not know the answer, so he asked this Hamilton and the entire mathematical community, what is the minimum number of colors required to color the different states of India, or for that matter, any country, so that adjacent states, that is states which have a common border, will not have the same color. If you know the map of India, you see that Kerala, Karnataka, and Tamil Nadu have common boundaries. Each of them have common boundaries. So as per the rule, I will require at least exactly 3 colors to color these different states of India: Karnataka, Kerala, and Tamil Nadu. So minimum number of colors required is at least 3. I will require these notions later. I put it in the simplest form. No mathematics was used. So that's the situation. I will come to this point later. Suppose you are asked to trace this figure without lifting your pen and without retracing it. That's the usual puzzle that you see in school children. If you don't know graph theory, you will be finding it difficult. But if you know graph theory and some theorems in graph theory, you can easily say that whether can you trace this figure without lifting your pen or retracing it. You take the picture of this photo and get me the answer later on, or through my email or WhatsApp. Okay, fine. So whenever there is a symmetric binary relation, you know, if you take any two things, either A is related to B or A is not related to B. Till the moment of this talk, I was not related to Professor Kolappan or Professor Kamal Kumar. But when we started talking, we became friends and we became related. So A is related to B or A is not related to B. That is what's called the Aristotelian logic or dichotomy. We have on or off, yes or no, black or white, and we have the yin-yang symbol also. So if A and B are objects and represented by points, and if A is related to B, then connect them by a segment, then we say that we assign a value 1 if A is related to B and 0 if not. We have a binary symmetric matrix, what we call the adjacency matrix, corresponding to a graph with the vertex set of cardinality n with a matrix of order n. So what I want to repeatedly say is that a graph is essentially a binary symmetric matrix. Or put it in the language of computer science, adjacency matrix, which is a binary symmetric matrix, is a data structure for representing a graph in the computer. So the simplest and the most faithful representation of a graph is by symmetric binary adjacency matrix. This is the point that I wanted to tell you. So 0 is related to 1. There exists an edge between 0 and 1. So 0 is not related to 0. 0 is related to 1. 0 is related to 2. 0 is related to 3. 0 is related to 4. So I get 4 ones in each row in that first row. Similarly for second vertex 1 and so on. So I repeat that whenever I have a binary symmetric matrix, I have a graph, and conversely, whenever I have a graph, I have a binary symmetric matrix through the relation between various elements of the graph. So we pay tribute to Arthur Cayley, who was responsible for the theory of matrices, and James Joseph Sylvester. Recently, I found, using the mathematics genealogy of the American Mathematical Society, that there is a very exciting moment which I shared with my friends in India and abroad, that I am connected to Arthur Cayley in 6 steps through my guru, Wazir Hassan Abdi, Ratan Agarwal, Wilfred Norman Bailey, Louis Joel Mordell, and Henrik Frederick Baker. They are all British mathematicians with Arthur Cayley. So myself and Arthur Cayley are related to each other by 6 steps. That is the advantage of going through the mathematics genealogy project of the American Mathematical Society and get excited. You may not know. I didn't know that I am related to Arthur Cayley in 6 steps. So whatever we do is basically a mathematical modeling, finding applications in physics, biology, computer science, economics, psychology, linguistics, philosophy, sociology, and so on. Basically, a mathematical model is either a black box model or a white box model. And there is a wonderful quote by G.E.P. Box, a British statistician, that all models are wrong. I cannot fit a perfect model, but some are useful. That's all possible. By looking at the models only, that we are able to know what is the structure of the or difficulty of the problem. So it's a black box model or a white box model according as we have an a priori information on the system or not. But practically we use somewhere between black box and white box models to analyze any problem. Major classification include linear versus nonlinear, discrete versus continuous, deterministic versus probabilistic, and so on. We'll be concentrating on dynamic discrete model. Dynamic model means something keeping on changing. First example, obviously, is that of the epidemiological network, which is shaking all over the world with the coronavirus 19. So graph theory in the information age is essentially the applications of computer science and other aspects of computer science like AI and machine learning to extract maximum possible information from a data source through what we call networks. So starting from simple problems of bridges and chessboards, graph theory in the information age has reached World Wide Web, Facebook, brain network, epidemiology, and beyond. So I'll spend about 5 minutes to talk about the SARS-CoV-2. You see in the newspapers and TV channels terminologies like contact network, corona cluster, super spreaders. All these terminologies are based on epidemiological network. Thanks to the first model, which was realized by Ronald Rose, a medical doctor. This is Ronald Rose, who got a 1902 Nobel Prize. You know, Nobel Prizes started in 1900. So he is the third or second set of people who got Nobel Prize in medicine for invention of malaria and so on. So the basic model that they used in attacking the malaria, believe me, is still used by the epidemiology community, even analyzing the COVID-19 data. So the basic model is what we call the compartmental model. The population is assigned to 3 compartments: SIR, susceptible, infectious, or recovered. This is a beautiful book which who wants to study further on mathematical epidemiology by Fred Brouwer. The title of the book is Mathematical Epidemiology, Springer publication. And this is how the mathematicians or epidemiologists or immunologists point of view of how does the coronavirus look like. Okay, so what we do here in the SIR model is to divide the entire population into 3 compartments. Susceptible means who is likely to get the infection. Infectious means already got infection, and recovered or dead. That is, after the infection, everything is over. As far as statistics from India is concerned, hopefully it is also for Raman, that now we don't have cases of COVID-19 as per government records in India. Okay. So interestingly, this is an interesting information. How did you get the shape of the coronavirus just like that. It is an imagination, and the disease that has put the entire world on pause is easily communicable, and to human eye, it is entirely invisible. So imagination of medical doctors and mathematicians and computer scientists is what we see as a shape of the coronavirus. We are all using masks because the pandemic is spread, usually transmitted via droplets during close proximity interaction. So very little is known about the dynamic patterns of the close proximity interaction. That's why we are supposed to use face masks. There is an extremely close relationship between epidemiology and network theory that dates back to 1980s, while the network that is generated provides insights into the epidemiological dynamics. So I repeatedly say that the moment water droplet goes out of your mouth or nose, the pattern of the spread or travel of these droplets cannot be predicted at all. That causes the spread of coronavirus faster than what we can expect. There is a notion of super spreaders. I'm not going to spend on that. There is a strong relationship between the contact network and the epidemiology. This is discussed in the Journal of Biological Dynamics. The science of networks has revolutionized research into the dynamics of interacting elements. Whether it is epidemiological network, or the brain network, or the protein-protein interaction network, or communication network, or even other new networks like real-world networks. There is a strong interaction between computer science to neurology, and even from social science to statistical physics, wherein mathematics, computer science, and different areas of mathematics like matrix theory plays a wonderful role. So let me tell you, my dear participants, that almost all knowledge domains have become highly interdisciplinary, or rather multidisciplinary. Those days where a mathematics teacher can sit in his room and read only mathematics and talk only mathematics and do only mathematics, those days have gone, those days have vanished from the knowledge domain. The subjects are interdisciplinary. To talk about the mathematics of the information age, you require constant interaction with the other communities like computer science, electronics, physics, chemistry, whatnot. So my request to my fellow participants is that start interacting with other areas, try to become a master in one of the areas and start interacting with the other areas, then only you can flourish, you can get more knowledge. So this is the picture of what happened. I'm not going to spend more time. So suddenly, because of the intervention of the vaccination, I hope this is the case with Oman also, blue, that is not immunized and but still healthy, became red because a lot of people became sick and contagious. So finally, with the intervention of the spread of contagious disease is contained through vaccination and so on. So blue people, which became red, finally became yellow with a few reds and few blue. That means that sociologically or epidemiologically, what we feel is that the virus is under control. Okay. So I'm moving in the right direction of explaining to you what is called the real world networks. Biological networks, metabolic networks, food web, neural networks, gene regulatory networks. If you come to linguistics, the science of languages, we have the semantic networks and language networks. So this is the protein-protein interaction network of the protein yeast. This is the language network. When you collect so many words, there is a definite rule or definite grammar by which I can connect each word with the other. I am talking in a webinar in Muscat. I cannot write it as I, webinar, Muscat, talking, to. Okay, so there is a definite order, or there is a definite networking, or there is a definite relation between various words in the English or any language. And there is a definite rule such that I am talking to, like. May I share at this point that I had studied pre-degree course in a college nearby. And I'm very happy to share with you that my second language for my pre-degree was Arabic language. Those times, that is about 35 years ago, more people were from India and Kerala were going to Middle East. So one of my brothers and friends told me that you better study Arabic so that you get a job in Middle East. I didn't get a job in Middle East, but I studied Arabic. So I know Quran. I've studied one chapter in Quran and also some Hadith. And I'm very proud and happy to tell you that out of the 4 students who opted for Arabic, I got maximum marks. So something, a personal information which I would like to share, because suddenly I talked about the language network. Okay, so there are networks everywhere. There is a definite pattern for the networks, believe me. Though it is highly complex, there is an order in it. That's why we people are able to study these real world networks, which is dynamic. Dynamic means it is not static. Dynamic means what? It is keeps on changing. You know, every second there is a new website or new website created and linked with another website. Each second there are new neurons coming up in the human brain and getting connected with other neurons through synapses. So in all these real world networks, there are 2 things which you should know, what are called hubs and authorities. In the case of epidemiological networks, the super spreaders are nothing but hubs. What is a hub? Hub is that represents a page that pointed to many other pages, while a good authority represents a page that is linked by many different hubs. Fine. So associated with every network, there are 2 parameters, what is called hubs and authority. Hubs points to maximum number of pages. So in the case of a network of, say, political leaders, world political leaders, you may have authority hubs like the President of USA, President of Oman, the King of Oman, and President of India, Prime Minister of India, and such people. They form hubs. So a hyperlink-induced topic search, its algorithm was designed by an American mathematician, John Kleinberg. And in any network, for that matter, identifying the hubs and authorities are not easy. So therefore, in any network, there are 2 scores for each page. One is its authority. Authority means how many links or how many links are connected to that particular page. And other is hub value, which is how many links are connected from this network, from this vertex or node. So there are 2 parameters involved in any network. I repeat, it is authority and hub. Come at the notion of a citation network. You know about citations, and somebody, while introducing me, told that my X index is 15. It's what's called the Hirsch index, another scientometric parameter for assessing the work of a researcher. There are mathematicians with citation index as many as 1,000. H index is 1,000. I will introduce you some of them. H index is 15, means at least 15 papers of mine has been cited by at least 15 mathematicians. That is what is called the H index. So we have a citation network, but there is a difference between this citation network and the World Wide Web or other networks, because there is an arrow of time. See, suppose I am writing a paper in 2022, I cannot refer a paper in 2025. whereas I might have referred a paper in 2020 or 2015 or 2000, right? Hope you got the point. So the citation network is, there is an arrow of network that becomes a directed network, right? So when you have, say, 6 people, 5 people here, A has referred paper from B, and B refers a paper from D, and D refers a paper from C, but C refers a paper from D, A also refers D, B also refers D, and so on. So as I told earlier, if I write a paper in 2022, I cannot refer in advance. I cannot refer a paper in 2025. It has not come out at all. In fact, several researchers are fooled by the notion of impact factor. I may touch upon the notion of impact factor now. I'm not sure. Yeah, impact factor is there. Several journals, bogus and fraud journals come out with saying that they have a very high impact factor, and the journal is just 2 years old or just 1 year old. They're declaring impact factor is highly fooling and cheating. Okay, so impact factor or citation analysis is very important when you get accreditation and promotion and so on. So what we call by impact factor is the average number of citations per paper published in the previous 2 years. So I need the information about the journal that it is at least 2 years. What I mean is, to look at the impact factor of a journal in 2022, I should have information about 2021 and 2020. Based on this only, we are going to get the impact factor of this particular journal for the year 2022. Fine. Something surprising. There is a notion of phylogeny, which is related to graph theory or mathematics in particular. What is phylogeny? After reading articles on phylogeny and all that, we feel that biology is more of mathematics. You will see later that the brain, human brain, or any animal, brain of any animal is more mathematical than physiological. That is something interesting. That's what I told you. Graph theory and network theory is exploding like anything, finding applications in many, many different, seemingly different areas. So what is phylogeny? Phylogeny is the history of the evolution of a species or group, especially in reference to lines of descent and relationships among broad groups of organisms. The fundamental principle of phylogeny is that plants or animals of different species descended from common ancestors. This is a highly complex study, that is theory of phylogeny. What we understand is, it's difficult to look at the species of animals who originated like that of a human being, like Homo sapiens. All Homo sapiens. We believe that it is all inherited from a monkey, right? So looking at the chart, the phylogeny chart, in fact, it's a phylogeny tree, believe me. It's a graph theoretical notion. Phylogenetic tree. So in medicine, phylogenies have been used to trace the origins and transmission rates of infectious diseases. That is something surprising.
ಒಂದು ಲೋನ್ ಕೊಟ್ಟಿದ್ದಕ್ಕೂ ತೊಂದರೆ ಆಗ್ತಿಲ್ಲ ಅವ್ರಿಗೆ. ಈ 15 ಲಕ್ಷ.
Hello? Okay.
Professor, you can carry on. Professor.
Okay.
Yeah.
Thank you. Phylogenies have been used to trace the origins and transmission rates of infectious diseases, including SARS-CoV-2, believe me. Dengue fever, influenza, AIDS, SARS-CoV-1, and so on. So phylogeny, or the study of origin of species, has become a highly demanding interdisciplinary area of research, which requires hardcore mathematics, in particular graph theory and network theory. Now, this is a famous network which all of us are involved, the Facebook network, thanks to Zuckerberg, Mark Zuckerberg. You may be surprised to know that the theory of Facebook and algorithms of page ranking, etc., were done by these people when they were just master's students. They were doing master's, MTech, in some of the universities in US. And it was there that they thought of the ideas like PageRank algorithm and this Facebook and mathematics behind this. So Facebook network is a huge network with more than 2 billion and active users. As per the statistics, India has 270 million active users. And in Oman, as I understand from the internet, according to 2022 statistics, it's about 1.30 million. 1.30 is not a small number. And to study the properties of networks formed by 1.3 million or few billions, it's not a joke. So what is the basic principle of Facebook? The Facebook is actually a faceless book in some sense, because we are not seeing the faces. Still, we say that we are friends. That is the basic principle of Facebook. What is the basic principle? Friend of a friend of a friend is a friend. So there is a chain of friendship. I may not be a friend with the Professor Kamal Kumar, but I got friendship through my friend Shajid. So common friend is Shajid. Did you get my point? So we have a common friend, and A is related to B not directly, but through a common friend. Believe me, there was a spread of epidemics in the United States a couple of years ago, when I think George Bush was the president. Several people started dying in a particular area, and an emergency meeting of all medical doctors, epidemiologists, immunologists, mathematicians, computer science people, other medical doctors, pathology people, all were invited. And believe me, that was the solution for this particular problem of spread of the epidemic was contained by a wonderful research team of epidemiologists and mathematicians. How come mathematicians come into picture is that between the patients and the bystanders or relatives of the patients, there was a common friend. Can you guess who is the common friend?
Doctor.
You get my point. There are patients who are inpatients sitting inside the hospital. Bystanders are outside the hospital. But even those bystanders started getting this disease because of a common friend, common point. Who could be that? The medical doctors or nurses? Nurses in particular. Okay, so nurses were interacting with bystanders, and nurses were also there with the patients. So that was the common friend. That was done by a mathematics and epidemiology network people, and that was a great relief for the US government. Okay, so in this picture, so this friend is a friend of this friend directly or not directly. So for example, this and these two people are not related. They are not directly friends, but they are friends through chain of friends. So the basic principle of the Facebook with a few million and billion vertices is the fact that friend of a friend of a friend can be a friend. They may have a common friend. And look at the distribution of the common friends. That is how it is done for the analysis of the Facebook. Believe me, there is a new branch of mathematics called Facebook mathematics, which involves matrix theory, graph theory, computer science, and so on. In all these Facebook, there is a community structure. In all real world networks, all social networks, there is a community structure, isn't it? Even look at those participants who are attending this program. I cannot see a lawyer. I cannot see a chartered accountant. I cannot see a civil engineer attending this, maybe a civil engineer at the most. Definitely there is no chance of an economist or a lawyer or another professional people attending this workshop, this webinar, because the community that we are interested in, at the most computer science people, IT people, mathematics people, and physics people. So the community structure in this particular network is easy to identify. It is the small community. So social network
Civil engineer here too.
Based on common location. All those people of my friends who are in Muscat, it may be different from what is happening in Kuwait or Dubai or Qatar or Delhi or New York or Cochin. So several people with common interests common occupation and common location. That is what's called a community. That is a substructure within the network. I again explain what is the substructure here, or subgroup, or the community. Community consists of all those interested in discrete mathematics, all those interested in computer science, maybe at the most electronics or IT. As I said, in this community or in this group or subgroup, substructure, that is what is called the community structure. And in general, for any social network, identifying the community structure or identifying the hub of that community structure is extremely difficult. Fine. Okay. As I said, community structure refers to the occurrence of groups of nodes in a network that are more densely connected internally than the rest of the network. I suppose the point is clear. When you have a community structure or community network, that doesn't mean that I am not at all interacting with somebody else. No. But I am interacting more with my community. That is the community behavior. Right? Finding communities within an arbitrary network can be a computationally difficult task. There are some algorithms for detecting community. I suppose the notion of community is clear. Let me check whether you have understood. So I will show you this figure. You can easily identify the communities. Am I right? That diagram itself says something about the community. So is this a community? Come on. You can unmute if possible, or we'll discuss it towards the end. Could you identify the community? This is a community, right? This is a community. This is a community. This is a community. This is a community. This is a community because these people are interacting more than some people outside. For example, this gentleman is related to this gentleman. That's all. This is related to this, and this is related to this. So what does it say? In community, in substructures, they are more closely related than outside. So this is a network of something, I don't know, which 5 communities identified. Are you following me? You look at the religious network. There are Hindus, Buddhists, Muslims, Christians, and the Sikhs, and so on. They identify as the community of the religious community. There may be a community computer science studies who follows mathematics. Within mathematics, there are people who are working in differential equations, in fluid dynamics, in graph theory, in matrix theory. So a community may itself have substructures, several substructures, right? So identifying these communities is not easy. This is what I told just a couple of seconds ago. Mathematics is entering fundamental biology, the theory of evolution. Something surprising. Just remind me, I have written an article. In fact, one article is coming towards the end of the month. Graph theory 1736, 1936 and beyond. There are two-part article. One is already published in July. I can send you the article which says something about all these things. A general point of view of the evolution of graph theory, as well as new techniques of graph theory being applied to look at the study of evolution. See, Charles Darwin is an excellent British biologist who lived in 1809 and 1882. What is something surprising is, in a new paper appearing in Communications Biology, a multidisciplinary team of scientists in Austria and the United States identify a possible way out of the conundrum. The conundrum is biologists and biological researchers were not able to completely analyze the evolution of species. Evolution of species by Charles Darwin through principle of natural selection. There is a definite natural way by which evolution has taken place and species have come that is still unexplored, like the Genome Project. You know, genome, few crores of genomes are involved in the Genome Project. Biologists are still trying hard to analyze the complete Genome Project. If you can study the complete Genome Project, we can assess who we are really. You may wonder, you may know that the Medicine and Physiology Nobel Prize for 2022 went to a group of scientists, doctors, who looked at the spread of epidemic by looking at the Neanderthal man species origin. How few thousand years ago people lived, Neanderthal men. By looking at the structure and species of the Neanderthal man, we were able to look at the spread of the COVID-19. That was what for that they got the Nobel Prize. So graph theory helps explain natural selection. That is something exciting for a graph theorist or network theorist or a computer science. In evolutionary graph theory, this is a new branch. I told about the origin of graph theory that was as early as 1736. This is 2020. So in the slide I showed in the beginning, I related several years like 1736, 1926, 1936, 1950, then finally 1999, and then now it is 2020 that is playing a wonderful role in the development of network theory, graph theory, and information theory, and so on. Okay, right. I'm not going into the details of how graph theory helps in natural selection. It's a growing area. People are still doing research. So this is the gentleman, Martin Nowak, who is director of the program for evolutionary dynamics. This is Martin Nowak, and this is the great Charles Darwin. His autobiography is excellent, international bestseller. So the problem was that biologists had only loose ideas about how specific population structures might affect natural selection. Very surprisingly, to find more generalizable strategy, Martin Nowak turned to graph theory. That's a very, very exciting moment for network theory and graph theory people. Unexpectedly, something like God-given, that biologists are now started knowing more about networks. That is quite exciting and quite challenging. That is where the interdisciplinary research takes place. I repeatedly say to my dear young participants that unless you are capable or you start doing interdisciplinary research, by connecting areas, you have to read a lot, maybe. You will not be able to get nice problems. I've been at this for the last 35 years. That's why I'm dealing with authenticity. Out of my experience, that unless you move out and discuss with people, you will not be able to know yourself, your limitations, as well as your strength. And that is how only research is possible. So this is an article in Malayalam which I wrote about the human brain network and the virus immediately after the this epidemic started. Okay. Fine. I suppose I may need about 20 to 20 minutes more. Fine. So I will explain in detail. Now look at the human brain. 86 billion neurons is what's called the human connectome. It's a highly connected mechanism, isn't it? Human brain is highly connected. It's at the time the network is a sparse network. Though we have 86 billion, that is 86 into 10 raised to 9 neurons, each neuron connecting with another neuron through what we call the synapses. That's what you have studied in the school biology. Only very few neurons are getting connected to neurons. Average degree or average connections is only 7,000. Did you understand? I shall repeat again. We have got 86 million neurons. huge number, 86 into 10 raised to 9. But not all 86 billion neurons is connecting to any other neuron. You know, each neuron connects with any other neuron through what are called edges, what are called arcs, what are called synapses in biology. Right? What I told you was, average only 7,000 neurons gets connected to other neurons. Even that is a huge number because we have got 86 billion neurons. So some neurons are not connected at all. So if you look at the 0-1 matrix, the matrix which I told in the very beginning, because of the nice behavior of these neurons, that not every neuron is getting connected to every other neurons. It is not related. Therefore, there are so many zeros and less number of ones. Such a matrix is called a Sparse matrix. That is an example of a small world phenomenon. I will come to that point towards my end of my talk. So this is a beautiful book, Graph Theoretic Modeling of Brain Connectivity. So after hearing me for past about an hour, you have a very confused idea of what is graph theory, and I myself is confused because it gets applications in so many unexpected, exciting areas. Graph theory is growing like anything. As far as mathematics is concerned, or for that matter, any other knowledge domain is concerned, computer science and information technology and information theory is helping us definitely to explore the various structures through programs and apps and so on. Fine. So network structures in biological systems and in human society is a beautiful book by Alexander. This is how the brain looks like. Several types of connections, meshes. I heard recently, or I found recently somewhere in a book, that thought process takes place in a triangular grid. When people start thinking, each neuron gets affected to get excited and attacks another neuron. So we have got meshes, hexagonal meshes, triangular meshes, and so on, but mostly triangular meshes. That's what I understand. Surprising. So the analysis of the structure of the human brain itself is a highly complicated area of science. Highly complicated. I can coolly tell all these things, but if you look at a medical doctor or if you ask Martin Nowak how complex the system is, it's extremely complex. But advancements, research taking place in these areas are worth mentioning, most recent being the 2022 Nobel Prize in Medicine or Physiology. That's what I told you. Human brain uses a grid to represent space. It's a grid. I have a point here, I have a point here, I have a point here. I'm connecting through, these neurons are getting connected through the synapses by grids. This is the 2010 paper that grid cells that act like a spatial map in the brain have been identified for the first time in humans. Recently, I heard a talk from a professor from Canada, an Indian professor, Professor Ram Murthy, who explained that the complete mechanism of the brain network has been done only for one species, one type of organism species. I don't remember its name, but it has got only 300 neurons in its brain. You know, there are organisms with 9 brains or 2 brains, 3 brains. Unfortunately or fortunately, we have only 1 brain, and that itself is enough, isn't it? We are highly complicated with the 1 brain itself, but with a few billion neurons. So there are species with less number of neurons, and for that, complete brain mapping has been done for only 1 species. That's what I understand. To study how does the brain of that species work. The human brain network has not been identified, has not been studied completely. We don't know even now how does our human brain work. Research is going. Why are we interested? We have several brain disorders like schizophrenia, Alzheimer's disease, and there are several diseases which affects human brain. So the way in which human brain is connected makes us the study of Alzheimer's disease easier. This is one of the most recent papers which came in 2020. If you Google brain connectivity and brain networks, you get wonderful number of research papers which deals with, at least the introduction part of the paper is readable, understandable, because you know what is network theory and graph theory. So this is a paper from Georgia State University. It says the new insight into brain connectivity, which came in 2020, which helps us understand and cure, if at all possible, some brain diseases like Alzheimer's disease, schizophrenia, and there are several disorders. When you are learning, important changes take place in your brain, including the creation of new connections between your neurons. So another appeal to my participants is start reading. The brain gets activated. When the brain gets activated, it is less chance that you are getting a brain disease. So when you are learning, important changes take place in your brain, including the creation of new connections between your neurons. This study is what is called neuroplasticity. I have a friend in my university biotechnology who works in neuroplasticity. How does the human brain work? You may be surprised to know that only recently that people knew that there is a GPS inside your human brain, just like there is a GPS in your car. The GPS tells you where to go, where to stop, left or right or straight, isn't it? How many kilometers, how many meters I have to go? GPS calculates and tells me. So just like GPS in the cars and automobiles, there is a new theory which got Nobel Prize in 2014, that there is a GPS inside the human brain. I don't know, I have included that slide. If not, that is the information. So the more you practice, the stronger these connections become. That is the very exciting branch of neuroscience called neuroplasticity. There are two books which I recommend. Of course, these are not the only books. So please Google, you will get Network Approaches to Diseases of the Brain. What I want to convey to my dear participants is just an important information that you feel like reading, because the moment you talk about brain connectivity and brain network, you should not get irritated or desperate. There are network theoretic languages which I will discuss in another 2-3 minutes, which will take you to something interesting and exciting as far as network theory people are concerned. So system theory, functional network as well as structural network. What is functional network? That is the medical doctor's argument. Though I am a mathematics man or a graph theory man, I cannot do brain surgery. I cannot do that. The help of a medical doctor or a neuroscience person or a neurologist is required, isn't it? Brain surgeon. Brain is the most complicated part of the human body. This is the CPU, central processing unit. It does a lot of fun when people started thinking and so on. I'll show you other interesting information that why only Albert Einstein could think about E is equal to mc square. Why not Vijay Kumar or Kamal or Shajit? What is the difference between our human brain, our brain, and Einstein's brain? You might have read in papers that Einstein's brain was removed within 7.5 hours of his death to analyze what is special in the brain of Einstein. The brain of the great communist leader Vladimir Lenin also was kept like this. How we could think about the revolution? how he could think about the communism. Albert Einstein's brain was operated upon several times. Nothing special was obtained, but physiologists say that he has got a brain with a better connectivity. And my dear friends, connectivity is a network theory or graph theory notion, how well the brain is connected. Fine. Okay. I'm slowly towards the end of my show. So this is something like World Wide Web. In the 1970 May issue of Popular Science magazine, Arthur Clarke, whose photo is seen there, is a famous popular science man who expected as early as 1970 Internet or World Wide Web was not there in 1970. Hardly computers were there in 1950s. Internet and the World Wide came only in 1978. Fine. So he predicted, just like a science fiction, satellites would someday bring the accumulated knowledge of the world to your fingertips, using a console that would combine the functionality of the photocopier, telephone, television, and a small computer, allowing data transfer and video conferencing around the globe. That is precisely what I am doing now. I am talking to you virtually. It is virtual because, so I cannot see what is happening in the University of in Oman. Okay. I don't know whether people are around there. Are there people? I see 174 participants, but I don't know whether they are connected or not because I am talking to them or I am allowing a data transfer through video conferencing or webinars. That was predicted, that was felt like by people like Arthur Clarke as early as 1970, and that is nothing but the World Wide Web. We should salute Sir Timothy John Berners-Lee. He is just nearing 70, who got knighthood from Britain, who is to be called the father of the World Wide Web. He is also the father of HTTP, a protocol, which all he did when he was in the CERN laboratory in 1989. I had made a mistake by saying that Internet and World Wide Web came in 1978. No, sorry, it's 1989. He is currently the director of the WWW Consortium, World Wide Web Consortium. He is a professor at the University of Oxford as well as MIT. His invention of World Wide Web was not patented. It's not patented. He got Fellow of Royal Society Fellowship in 2001, and he became a Sir Knighthood in 2004. Okay. This is another gentleman, Felix John Kleinberg, professor of computer science. We are slowly introducing to the theory of small world phenomena. So in about 10 to 15 minutes, I will stop. Facebook is small world. This is what precisely which I told earlier. I don't know each of them, but I know each of them or maybe some of them through my friends, already known friends. So I can search whether I know somebody. Look at Facebook profile of some people. You like, you send messages, you post photos, many things. Several interactions are taking place in the internet and Facebook and so on, isn't it? Two persons who are 5 friends links away could navigate from one person to the other by knowing only the friends at each point, but not knowing anyone's friends of friends. That is precisely the connections that is established in the Facebook. It is searchable. I can search whether I am an idea. Okay.
Thank you.
In that brain network or Facebook network, there is another notion called clustering coefficient, which was invented by Duncan J. Watts and Starogitz in 1998. It's a measure of the degree to which nodes in a graph tend to cluster. We look at the network of all film actors, whether it is Bollywood or Mollywood or Tollywood or whatever it is. You know, Amitabh Bachchan plays a key role, right? So there is a clustering towards the network of Amitabh Bachchan, right? So many people getting related to Amitabh Bachchan by acting in movies which are acted by his friends and so on. That's how the clustering goes on. Yeah. In all these networks, real world networks, I gave you language network, semantic network, protein-protein interaction network, brain network, internet, the World Wide Web, whatnot. All the real world network, there is a power law. What is that power law? Which becomes richer in economics. What's called the preferential attachment. I will tell you a simple story which will make you understand what is this power law. I come to Muscat. I don't know when I can come. My friends can invite, I can come. Okay, take it as a joke. I come to Muscat and I want to buy some things from a shopping mall. I ask my friends Kamal or Sajid, where should I go? I want to buy some sweets or dresses for my family. I will ask my friend Sajid or Kamal, where should I go? What will they do? They will take me to a shopping mall where they go, right? Or if I am unwell, they will take me to a doctor whom they go. They don't take me to an unknown person, strange doctor. So number of visitors to that particular supermarket or mall increases. That is what's called the power law. Number of patients of the doctor increases because so many people. Next time some other friend of mine goes to Muscat and is unwell, I will definitely recommend that particular doctor to go and visit, right? So the connections gets more and more. That law is what's called the power. If I put in slightly mathematics, if you look at NKG, the number of vertices in the graph having degree k. What is the degree distribution? That number, degree of 1, 2, 5, 7, etc. Degree is 5 means 5 people are friends with me. Now 180 people are friends with me because 180 people are watching this webinar. So look at the number of people and the degree in which it is related. That distribution is called degree distribution. You look at the number of degrees of each vertex and divide by total number of n. It says that this nkg by n is asymptotically proportional to k power minus beta. And that beta, which is usually greater than 1, is called the exponent of the power. So nkg by n is proportional to k power minus beta. So if you take log nkg is log n minus beta log k. What is this? This is nothing but the equation y is equal to mx plus c, a straight line. So log plot will be a straight line with the slope minus beta. Did you get my point? Nkg by n is proportional to k power minus beta means nkg by n is equal to some alpha times k power minus beta. You take log, what you get is log nkg is equal to log n minus beta log k. So y is equal to mx plus c form, where m is the slope, basic analytical geometry. So log plot will be a straight line with slope minus beta. And there is a strong research group in USA, physicist basically, who has a wonderful paper in the Nature, which showed that for the World Wide Web, the power of exponent of the power law is 22.1. So this is the famous Poisson curve, bell curve, Poisson distribution. And this is how the power law distribution works. That is a few hubs with a large number of degrees. Fine. So in the human brain also, in the World Wide Web also, there are certain websites which I have to pass through. There is no way. We are not seeing it. That's all. So World Wide Web forms power law. Protein-protein interaction networks form power law. The inverters form power law. It's a common law which is followed by all these laws. That is the excitement, and that is what's called the real world network. So these are good books for reading. Evolution of networks. There's another notion in mathematics, what's called fractals, chaos. I'm not going to that. There is a relationship between power law, fractals, and chaos. That is something surprising, which I told in the beginning. Something unexpected, something exciting takes place in the research arena because new things are getting connected, getting same. That takes you to the wonderful philosophy that there is only one God. Whether you pray Allah or Christ or Vishnu or Krishna or Sikhs pray God, Buddha, there is only one God. There is a commonness in the religious philosophy. Similarly, there is only one law which governs all the real world networks. That is surprising. Each moment, researchers say that this also belongs to power law. This also is a fractal. I find it quite exciting and surprising. As I told you, the invention of World Wide Web was not patented. It's actually free, isn't it? I can freely use my internet because big companies give money for that. So he got the Millennium Technology Prize, 1 million euros. But many people who use this World Wide Web technology became, multimillionaires, like Jeffrey Bezos of Amazon, Jerry Yang of Yahoo, Perry Omidyar for eBay, Mac Anderson for Netscape. All these are multimillionaires, billionaires. But poor, I cannot say poor, Tim Berners-Lee did not patent his invention of www, but instead he got 1 million euros and the Millennium Technology Prize. So the web is exploding, starting with 3.2 million hosts and 3,000 websites in 1994. On March 2022, it is 1.93 billion. That is 1.93 into 10 raised to 9 active websites are there. There are some inactive websites also. Nobody goes there. Fine.
3 o'clock ಗೆ ತೌಕಿರ್ದು ಈಗ ಕಾನ್ಫರೆನ್ಸ್ ಅಲ್ಲ ಕ್ಲಾಸ್.
How does the World Wide Web look like? World Wide this look like a ghost type. There is a central core.
ಮ್ಯಾಥ್ ಫಾರಂ ಅಂತ ಒಂದಿದೆ.
Hello.
ಫಾಲೋಸ್ ಅದರಲ್ಲಿ.
So there is a central core. Everything is connected. It's what's called strongly connected component. So this is the structure of the web that was published in a research paper in Nature. What exactly is the diameter of the internet? It's only 19. What does it mean? Technically, I can reach from every website to every other website in at most 19 clicks of the mouse. Fine. I recommend strongly these two books, Network Science and Course on the Web Graph. So I will conclude in about 5 minutes. So what are the nice properties of real world networks? One is sparsity. I told you in the beginning, it is massive, it is huge, it's complex, but fortunately it is sparse. Means, if you look at the matrix, there are more zeros than ones. Fine. It is small world. I can reach from any website or any object to any other object in few steps. Any two vertices of the network, real world networks are connected by a shortest path. This is a beautiful book by Duncan Watts. So two vertices having a common neighbor are more likely to be neighbors. Two sets of people who have a common friend are more likely to be friends. That's what is happening with 180 people sitting in front of me attending this webinar. They have become friends through a common friend from the university. So what is the philosophy? Most nodes are not neighbors of one another, but most nodes can be reached from every other by a small number of steps. As I told already, power law is actually the preferential attachment that the economics people do. Rich becomes richer. Those people who have been attracted to a particular person gets attracted. That's what I told in the beginning. So highly linked sites are there in the website. That is the reason big data analytics is related to that. You have got a huge data, how to store, how to analyze, how to conclude from the big data. It's a very highly challenging branch of science. So this is a hub, simple example I gave you, because this is the vertex to which more vertex are connected, right? So degree of this vertex is 7. So this becomes a hub. If you look at the universities all over the world, Stanford University, Harvard University, MIT, Caltech, Oxford, all these universities become attraction for so many people, right? So they are all hubs in the knowledge domain. Okay. Average degree is, total degree by number of vertices is 3.8. Clustering coefficient is 0.5. There are plenty of books which you can read. I strongly recommend reading the article by Fan Chung by the same title, Graph Theory in the Information Age, which came in Notices of 2010, American Mathematical Society. There's another great researcher, Amy J. Newman. This paper qualifies to be the most downloaded article from the website. Structure and function of complex networks. Barabasi, I will show their photos in a second. There's a protein-protein interaction. You know, yeast is a thing which we use in your cooking purposes, isn't it? In the kitchen. Have you ever thought of how many species of yeasts are there? Okay. How many species, how many different types of yeast? In Kerala, we eat appam. Appam with chicken stew or mutton stew or something like that. We use yeast to prepare this appam, this thing which we prepare. I asked my wife, what is how many different types of species of yeast are there? She didn't know, nobody know. I also didn't know before I reading it. Google how many types of yeast are there. That's protein-protein interaction. Proteins are the main agents of biological function. They are not functional in isolated forms, but they interact with each other and other molecules, like example like DNA and RNA, to perform their functions. They don't act in isolation. They are very idle, but they interact with other molecules like DNA and RNA. All these networks are also called scale-free networks. So a network is called scale-free if the characteristics of the network are independent of the size of the network. What does it mean? When the internet grows, or when the network grows, the basic structure remains the same. Even if some 10,000 new websites are added to the website, World Wide Web, nothing major is changing place. That's the property of scale freeness. And there is something very great taking place. There is a 6th degree of separation between every 2 human beings. That's what's called the human web. It is the grand idea that everyone is at most 6 steps away from any other person on earth. That is what's called the 6 degrees of separation. These are the pioneers who worked in complex networks. Look at Duncan J. Watts. His citation is 1,17,500 citations. Very, very exciting. H index is 63. So this is Duncan J. Watts. This is Strogatz. This is Barabasi. This is M.E.J. Newman. Google their websites and get excited about their H index, their wonderful contributions in computer science, IT, mathematics, and so on. I told you that about 6 parts. So you may wonder, I said that every human being is related to or connected to every other human being in the world with 6 steps. So I am connected to Joe Biden in United States. Right? I'm connected to the President of UK, the King of your country, by 6 steps. But the challenge is how to find that 6 steps. How do you reach that? So these are examples of 6 paths. In Facebook network, it's only 3.57. As Microsoft people proved. You know what did they do? There's a research of Microsoft, MS. After checking 30 billion electronic messages among 180 million people in various countries, Microsoft researchers proved that there is precisely 6 degrees of separation. A degree of separation is a measure of social distancing between people. But for Facebook, the researchers in Facebook proved that the degree of separation is just 3.57, or average is at most 4. What does it mean? Every member of the Facebook can be reached from every other member, not necessarily 6, but just 3.57 average. Exciting. So to conclude, our www is an infinite imaginary library. Number of web pages exceeds human population. 1.93 billion websites as on March 2022. You may ask me, why are we worried? The worry is because we need new mathematics, new information from computer science and IT, which we demand, because to study completely the structure of the World Wide Web, the new phenomena coming up, we need a new interdisciplinary approach. So this is a book which I suggest again, Scale-Free Networks, Complex Webs. I stop with the message of the breaking the chain. We can possibly think about possible interactions and collaborations. You are welcome to Kerala. Do research in Kerala. There are scholarships available for those who are not from Kerala attending this program. And you are welcome to Kerala, not necessarily for studies. You can enjoy the beauty of Kerala. It's what's called God's own country. We have this art form, what we call Kathakali, especially for the information of those not from Kerala or India. This is the beautiful houseboat passing through the banks of the river. It's backwaters actually, the coconut tree and all that. So thank you very much for hearing me for the last maybe 1 hour and 15 minutes. I invite collaboration with faculty members from the university, or for that matter, any university in Saudi Arabia, Oman, and so on. You are also invited to come to Cochin and have interaction with us. So wish you very best in life. And thank you very much, my dear friends and fellow teachers who gave me an opportunity to virtually come to Muscat and give this talk. And thank you very much.
Dear participants, if you have any questions, you can unmute your mic and ask your questions.
Introduce yourself and please ask me. Whatever I know, I'm happy to answer.
This regarding the large network where we have billions of vertices and edges. How this is going to be used in computer tool, how they are going to analyze, like an ordinary professor like us, like where we are seeing the graphs with very small data. So
Right.
how is our journey to reach there? How will we start our journey to reach there in analyzing all this big data?
Very good question. There are several apps, packages, algorithms. If you Google how to analyze the large scale real world networks. See, I told you most of the real world networks have the property that it's a small world. The matrix is sparse. So though it is huge and complex, matrix theoretically it's not a huge system because it is adjustable, it is tractable. So based on this fact, there are several packages, there are several programs which you find. For example, as you asked, how do you compute the cluster coefficient? It's a good question, isn't it? Yeah, I give you the network of film actors in India. That itself is a huge network. It's a changing dynamic network. How do you calculate the cluster coefficient? How do you calculate the exponent beta? Good question. Okay, so there are packages, there are researchers working in this type of real world networks. You can Google and definitely get it. If you fail, you can please correspond with me. I'll be able to help you connect with those people.
Thank you very much for enlightening, Professor.
Sir, good afternoon, sir. This is Sundareshwaran from SSN Chennai.
Hello.
How are you, sir?
Fine.
Fine, sir. Sir, I have now we are starting working on brain connectivity using centrality measures.
Sorry, I didn't hear. What's it?
Brain connectivity using centrality measures.
Okay.
So from EEG to construct a graph, then we analyze by using centrality measures. We have published 1 or 2 papers based on centrality measures. Now, instead of taking EEG, is it possible to take fMRI? From fMRI image to graph network, there are certain papers published.
Yes.
Is there any book?
Magnetic resonance imaging, fMRI.
Yes, sir. Is there any book relevant to that? It's published in.
As I suggested, I closed that sharing. There is a beautiful book by Olof Sporn, S-P-O-R-N.
Yes, sir.
That's according to me, that's a Bible which says fundamentals of all these things.
Okay.
How does these new techniques are applied and so on. And there are umpteen number of research papers on this area.
Yes, sir.
The point is, both network theory as well as fractal theories are combined. Okay.
Yes, sir.
For example, our retina network, that's what's called, diabetic retinopathy. The network gets a fractal shape. That's what applications of fractal science.
Fractal theory.
In medicine.
Okay, sir.
So the same network is really, studied as a fractal object as well as a network object.
Okay.
That's what I told you repeatedly. Told you that it is going to be an interdisciplinary study.
Yes, sir.
My limitations of medicine and physiology, it's limited. Yes, so I don't understand the hardcore, medical terms.
Yes, sir.
If I sit with a doctor who can explain to me, so try to form. In fact, Professor Ramamurthy gave a talk in our forum a couple of days back.
Yes, sir. I have attended that.
Yeah, very exciting talk.
Yes,
so biotechnology people, physics people, computer science people, maths people, and statistics people should sit together and form a group. Unfortunately, that culture is not there in India.
Yes, sir.
That's a problem, but we can start. We are hopeful.
Yes.
We are optimistic.
Yes. Yes, sir. Thank you, sir.
Thank you, everyone. Thank you, everyone. Dear audience, our resource speaker, Dr. Ambath Vijaykumar, is personally known to many of us, either as a researcher or as a teacher of mathematics or both. In fact, as Professor mentioned at the beginning of his speech, some of our teachers here in the University of Technology and Applied Sciences, Muscat, are his former students. It is indeed a great honor to express our sincere gratitude to him for spending some of his valuable time to share his knowledge with us. As a token of our gratitude, we would like to present the certificate of appreciation to our respected speaker, Dr. Ambat Vijay Kumar. I request Dr. Bushra to virtually award the certificate of appreciation and deliver the vote of thanks.
Thank you very
Thank
much.
you, dear Dr. Ambat Vijay Kumar, for the enlightening and highly informative talk. I am glad to thank the organizing team of test branches and students for being here with us today. Wish you all the best and have a great rest of your day. Thank you, Dr. Ambat. And please accept
you very
our
much.
certificate of appreciation.
In fact, I should thank Professor Kamal Kumar, Professor Golappan, and Shajid, my former friends, for inviting me to this forum. And I could see some participants from Kerala also. It's a happy occasion for me also. And I'm happy to share whatever knowledge I have at any point of time. And, collaborations and research is welcome, joint research is welcome.